This chapter is all about finding surface area and volume of three-dimensional figures, or solid figures as we call them. This section specifically is about finding the surface area and volume of prisms, which are three-dimensional objects with a pair of parallel sides. These parallel sides are typical two-dimensional figures like squares, rectangles, triangles, trapezoids. You're going to see later on we're going to have circles and other things, but those aren't called prisms because they have to be rectangular in nature. They have to have sharp corners and things like that. Now, the two sides that are unique are called the bases, and this is how we define the prism based on these unique sides. So rectangular prisms have bases that are rectangular. So these two are rectangular prisms. That's because I said prisms. That's because the special side is a rectangle. Now, obviously in the top one, that looks more of a square, but a square is a special rectangle. The top one, if all these three sides were or all of the sides on it were squares, this would be called specially a cube. But in general, it's called a rectangular prism. This one on the bottom, you can see that this is a rectangle, and so is going to be the kind of back side here. That will also be a rectangle, and these two parallel sides are connected by other rectangles. The rectangular prism is kind of the most simplest form of a prism because all of the sides are just rectangles. Now, a triangular prism, like we have on this one, has two parallel triangular sides. And what you'll see is that this side here, right, that's a triangle. And if you just kind of look under, that's also a triangle. And they're all connected, this side, and then if we go kind of back here, those are all rectangular sides. This would not be a rectangular prism, however, because the triangle is unique in that it is a different shape, right? So we call this a triangular prism rather than a rectangular prism with a triangle sides. No, the triangle are the special shape, so we're going to define it using that triangle, and the triangular sides are the bases of the prism. That's going to become important when we look at volume. Now this last one down here is a trapezoidal prism. Trapezoidal. That's because the unique sides, and on the back there, are trapezoids. All the other sides are going to be rectangles. Now, if it was slanted a little bit, you'd see that the sides would be parallelograms, but we really don't deal with that. That's a kind of more unique prism shape. What you're really going to be expecting here is some unique shape, be it a square, rectangle, triangle, trapezoid, and then rectangular sides on all the other sides. All right, for the surface area of prisms, you can really just think of it as the area of each side of the three-dimensional figure added all up. So if it's a cube, right, we're going to have 1, 2, 3 sides there, and then a fourth one is on the back. We have a fifth one on this side, and then a sixth one on the bottom there. And if it's a cube, all of the sides are going to be squares. So we just find the surface area of each of the what's called faces of the prism and add them all up, add all the areas up. For the general rectangular prism, we're going to have probably 6 rectangles on each of the sides, back side and then the underside as well. And then they're all going to be rectangles, just like the cube is base times height. That's how you find the area of a two-dimensional figure for rectangles, and add them all up. Now, a triangular prism, so I'll just say here, the area is base times height. You can also think of this as length times width, whichever makes sense to you. Base and height is going to be used for volume as well, but in a different kind of context. It's going to be important that you understand which context we're talking about. We'll talk about that more a little bit. Triangular prisms are similar, except we need to find the surface area of two triangles and then three rectangles. We have one rectangle here, two rectangles there, and on the back side it's going to be a third rectangle. And on top and bottom we have two triangles. The area for a triangle, say area for rectangle, area for triangle, is going to be 1/2 base times height. Of course, the base is like a flat line, and then the height's going to be like this distance here. It makes a 90-degree angle with the base. So that would be, take out some of this. This would be the base, that would be the height, and then you can calculate this singular side of the triangle face. And then you just multiply that by 2 because you have two of the exact same triangles on top and bottom, and then find the dimensions of the 3 rectangular faces, add those all up, and you're good to go. Now, a trapezoidal prism, same kind of idea. We have a trapezoid face here, and then one kind of on back. And you're going to find the trapezoid has base 1 is typically the longer base, base 2 is the shorter base. Then we have the height, which is the distance between the two bases to make right 90-degree angles with the two sides. And the area of a trapezoid, this is a triangle. Area of a trapezoid is the 1/2 base 1 plus base 2 times the height. That's what this blue line is here, is the height. So it's 0.5 times base 1 plus base 2 times the height. And then the other, see, we have 1, 2, this side right here is going to be a third rectangle, and of course on the underside it's going to be another rectangle. We have 4 more rectangular sides to add up to the 2 trapezoidal sides, and then so it's a 6-sided figure. So add up all those surface areas and you have the total surface area of this prism. I'll show you how to do all of this when I actually do some problems, but I just want to kind of get the groundwork laid, and then we can talk about it in practice. Now, the last topic is volume. Volume is quite easy to find. All you need to know is the area of the base of the prism. So this isn't the same thing as the area of the base of a two-dimensional figure. The base of a prism is the special named thing. So for a triangular prism, it'd be a triangle. Let me do it in purple here. This would be the base here, this triangle. For a trapezoid, the trapezoid is the base. For a rectangle, that would be the base. So you're looking for the special shape that defines the prism, and that is the base of the prism. There should be 2 of them, and they should be parallel on either sides of the three-dimensional figure. Now, this base, you multiply its area, which we already should have found from the surface area, by the distance between the other base just like it. So for the triangular prism, right, we have this red triangle here, and we have another triangle on bottom. The distance between these 2 triangles is the height of the three-dimensional figure. It's the same thing. This is the height. It's the same thing as this being the height, and it's also the same thing as this being the height. In fact, any straight line distance on this thing it's the same thing as the height. But typically it's going to be one of the side length measurements, whatever those look like. So you take the base, so the volume of a solid, or I should say prism here. Volume of a prism is equal to the base, which is going to be base area, which will be like the triangle or the trapezoid or the rectangle. whatever prism you have, and you're going to multiply that base area by the height, or the distance between the other base area. And that's how you find the volume. This will make more sense in practice, so let's look at that. All right, here I have 4 figures, and we're going to find the surface area and volume of these 4 things. So the first one here, you see we have a rectangular side. In fact, there's a lot of different ways you can look at this one, but I'm just going to look at this front face because that's just easiest in my mind, but you can do whatever kind of makes sense to you. But we have a rectangular prism here. This is a rectangular prism. And to find the surface area, we really just add up all of the sides. Now, for every prism, especially true for rectangular prisms, opposite faces are the exact same area measurement. That's because all of the measurements are the same, right? This height is 4.5 yards. This one here is 4.5 yards. Up here we have 2 yards, 2 yards. This is 3 yards, and that's 3 yards. That's because of the way a rectangle is defined. Now, we don't need to necessarily know all those things. We just need to know if we can find, I'm doing green here, the green side, the red side, and the purple side, we can multiply those by 2 because the underside here is also the purple. It's also the same dimensions of the purple. This side here is also the same dimensions as the red, and the back side is also the same dimensions as the green. So it's the same calculation. Okay. For the green side, let me get rid of these arrows. For the green side, the area is going to be base times height, or length times width, whichever makes sense to you. We have 3 yards, as you could say, as a width because it's a smaller, and the height is going to be 4.5. So we can just multiply that by 4.5. That's the area. There's just a flat 2-dimensional area of the green side. So we have 3 times 4.5. I'm going to grab a calculator. And we get 13.5. That's the area for the green. Now this is going to be in yards squared because area is a squared unit of measurement. For the red, we have 2 yards and 4.5 yards. So 2 times 4.5 gives us 9 yards squared. For the purple, we have, you can see that this 3 just kind of goes straight up to that side there, and this 2 goes straight up to that side there. We just have 3 times 2, which is 6 yards squared. Now, like I said, there are two of each of these sides. So the green, right, has a front side here, and if you turn the prism around, the very back side would also be green, right? I'm talking about this back side here, not this side. Or the top. We're talking about the very back side of it. Imagine turning the prism around in your mind. Okay, so we're going to multiply each of these by 2 to get the total surface area. So I'm going to say surface area equals the green times 2 plus the red times 2 plus the purple times 2. Adding those all up will give us the total surface area. Let's see, 6 times 2 gives us 57 yards squared. All right, now to find the area, or sorry, the volume of this 3-dimensional figure, that's really just the space inside of it, right? That's what we're looking for. There's a number of ways we can do this. I'm just going to look at this front face here. I'm going to find the area of that. Well, we already know that that's just the same thing as this green side because it's 3 times 4.5. And we're going to multiply it by the height, the distance between this side and the opposite side, which is the very back. And that distance is the same as that and that distance, which are all 2 yards. So the volume is literally just like all 3 of these dimensions multiplied together. That's really all we're doing here. We're multiplying all these 3 things together. Length or base times length times width times height. That's the same thing as the volume for rectangular prism. So we have 3 times 4.5. That's the area of the front face. And then multiply that by 2, the distance between the 2 faces. Doing that gives us 27. And a volume measurement is cubic. So it's going to be yards cubed. You can see that by having 3 yards times 4.5 yards times 2 yards. Yard times yard times yard is yard cubed. All right, for the next figure, for part number B here, we have a trapezoidal prism. You can see that because this face here, this front face, is a trapezoid. It's got 2 sides that are parallel and 2 sides that are not quite. We have a flat side and then we have an angled side there. That's what a trapezoid is. The rest of the sides, this side here, the underside, and then this side here are all going to be rectangles. So to find the surface area, we're going to calculate the volume, the area of all of the sides and add them up. So we have 2 trapezoidal sides, which are the exact same. We have the area of a trapezoid is going to be 1/2 base 1, which the bases are going to be the sides that are parallel, which is going to be, let me do this in purple, I guess, this side and this side. Those 2 sides are parallel. The other 2 sides, you can definitely see these other 2 sides are not parallel. So always take the parallel sides. It's going to be 6 meters on the top side there. And then this side is 18 meters. Okay. And then multiply it by the height, the distance between these 2 sides. It has to be a straight line distance. And that's the reason why these right angular sides were given. That means that this line here is straight between the 2 bases. It's not angled at all. It's completely straight between the 2. So we multiply this thing by 16. That's the height of the trapezoid, not the height of the prism, the height of the trapezoid. We're talking about 2 dimensions versus 3 dimensions. Okay. That gives us, let's see, 8 times 24, which is 192, and this is meters squared because it's an area. Okay, now we can, if we multiply this by 2, because we have this front trapezoid, and then on the back here, we have a trapezoid in the back there, so there's 2 of them. Now we need to figure out the dimensions of the other 4 sides and calculate the area. So just kind of trying to keep it in mind what we're looking at. We're looking at this side right here, this side, the back side here, and the underside. Not worried about the true trapezoidal sides. We already calculated those. Okay, for this bottom side, or this let's say right hand side, it has a height of 18. So imagine taking this out, and it looks like this. Is a height of 18, and then I actually do this improperly because the height is longer than the width, because the width is 14. This 14 is the same thing here and here. So that's the height and the width of the side triangle here. Sorry, side rectangle. So then the area of this is 18 times 14, which is 252. That's going to be in meters squared again. So we'll say, give a name to these. make it a little bit easier. This is rectangle 1. This is rectangle 2. On this side here, we have rectangle 3. And on the underside here, we have rectangle 4. So rectangle 1 is 252 meters squared. Okay, for rectangle 2, we have 14 meters, that's one of the measurements, and then 16 meters, right? 16 meters is the measurement for one side of the rectangle, and 14 is the other side. So let's do 14 times 16. Gives us 224 meters squared. Okay, now rectangle 3 and 4, these ones we can't actually see. And so you kind of have to visualize it, but you can still use the information given to figure them out. For rectangle 3 here, you see that 14 meters is one side. Let me stand it out a little more in red. 14 meters is one side, and 6 meters is actually the other side. You just try and picture moving the trapezoidal prism around to see that. It's a long, thin rectangle on the very top there. So we have 14 times 6, which gives us 84. And this is, of course, in meters squared. Finally, rectangle 4, which is on the bottom there. Rectangle 3 was this one. Rectangle 4, it has a 20-meter side. And we're looking at for this length here, right? That's the other side length. This side length and the other one. But this side length is the same thing as this one, which is the same thing as this one. And that is 14 meters long. So this is 14 meters long. So rectangle 4 is 20 times 14, which is 280 meters squared. Okay, multiply the area of the trapezoid by 2 because there's 2 faces of that trapezoid. And then all we have to do is add up all of these areas, and we have the total surface area. So the total surface area, I'll just say surface area, equals 192 times 2. Again, there was 2 trapezoidal faces that are the exact same. And then we have R1, rectangle 1, plus rectangle 2, plus rectangle 3, plus rectangle 4. Add these all up, 12, 24, and this is going to be meters squared. Again, it's an area, so it's always going to be in squared meters. Okay, I'm going to delete some of this stuff to make some room, because now we have to find the volume of this side. So the volume is going to be the area of the base times the distance between the first base and the second base. And the base of a prism is the unique side, namely the trapezoid. So we already know the area of the trapezoid. We found that right here. All we have to do now is multiply that number, 192 meters squared, by the distance between the 2 bases, which is the straight line distance, which is the same thing as 14 meters squared. So the volume of the trapezoid is 192 meters squared times 14 meters. And that gives us 2,688. This is going to be in meters cubed. That's the surface area and volume of this trapezoid. All right, hopefully we know what we're kind of doing here for this next one. We have a triangular prism. So now to find the total surface area, we need to find the surface areas of each of the sides. Now we have 3 rectangular sides. We have this side right here, this side, and then the back side is also a triangle, or sorry, a rectangle. And of course, the top and the bottom are triangles. So let's find the unique base first, which is the triangle. So the area of the triangle is 1/2 base times height. Now base is the whatever, in this case, this is going to be the base. That's because the height is given to us as this side right here. And the base and the height are connected by a right angle, which is given by that little square there. Let me do it in red. This little square here, that's a right angle measurement. That means that the two connecting are the base and the height. Okay. It doesn't actually matter which one you call the base, which one you call the height. You're just multiplying them. But always think of the base as one of the sides of the triangle. And the height is the straight line distance to the very peak of the triangle. Okay, this base is the same thing as this bottom side. So it's going to be 12, and that's in inches. And the height is 5 inches. So we have 1/2 base times height. 1/2 times 12 is 6, and 6 times 5 is 30. And this is going to be in inches squared because it's an area. Now we have 2 of those, so we're going to need to multiply that by 2 when we do the total surface area. Do 30 inches times 30 inch squared times 2, plus the other 3 rectangular sides. So we have rectangle 1, rectangle 2 is going to be this side right here, and then rectangle 3 is going to be the back side of this prism. So rectangle 1 is 12 inches times 15 inches, which gives us 180 inches squared. Rectangle 2, we have this tall dimension here is 15 inches. It's the same thing as this one. So we have 15 inches tall, and it's 6 3/4 inches wide. Okay, doing that times 6. It's going to be easier to type it in the calculator if we do 6 3/4. 4 times 6 is 24, plus 3 is 27. 27 divided by 4 gives us 101.25, or 101 1/4. And then rectangle 3, get some of this right. We have 15 inches is one of the dimensions, and 9 inches is the other dimension. So we have 15 times 9. Gives us 135 inches squared. So we can put those into our surface area calculation and figure out what that is. I got 476.25, and this is of course in inches squared, because it's a surface area, not a volume. All right. For in practice, right, if you have to find the surface area and volume of a figure or of a prism that you actually have in everyday life, you can obviously just take the prism and measure each of the sides and move it around, right? But for this type of thing, when we're doing it on paper, you need to be able to visualize it and change and move it around in your mind to be able to see which sides have which dimensions. Because that's really what the whole goal of this thing is, to understand how do you find the different dimensions without actually being able to, take a ruler to the side. And that's why all these numbers are given the way they're given, is because you can find all the dimensions with what is given. That's if you couldn't, there'd be no point in doing these problems. Okay, the volume of this is going to be the area of the base, which is the special shape, in this case the triangle. The area of the base is 30 inches squared times the distance between them. And what would that be? That would be 15 inches. That's the distance between the two triangular faces. So 30 times 15 gives us 450, and this is going to be inches cubed. All right, last figure, and arguably the easiest figure, because this is a cube. And a cube has every single face is the exact same. which means the surface area is going to be the exact same for all of them. And there's 6 faces, so we go 6 times whatever the surface area for one of the sides is. And you can just calculate that for this one. Length times width, or base times height, whichever makes sense, is just 7 times 7. We have 7 times 7. 7 times 7 is 49. 49 times 6 gives us 294. This is going to be in centimeters squared. This is a surface area, so it's centimeters squared. And that's only so easy because the cube has such a restricted definition. All of the lengths are the exact same. You can find the area of each of the surfaces. If that doesn't make sense to you, they're all going to be 7 times 7, and then add them all up. There's 6 of them. That's why it's 6 times 7 times 7. Okay, the volume is going to be the surface area of one of the cubes, which is 49. The same thing as for the rest of them, right? We found the surface area of the rectangle, the surface area of the trapezoid, and the surface area, or sorry, the area of just the face, the triangle. Whatever that special side is, in this case is 49, and multiply it by the distance between another, the other base side. There's a number of ways you can do this for a cube. Think of that as the first base, and this back one as the second. That means the height is going to be this distance here, which is the same thing as that distance, 7. So just multiply this by 7, and we get 343. And that's going to be in centimeters cubed. The cube is the easiest because really the surface area is just going to be 6 times whatever the area of one of the faces are. And the volume is all 3 dimensions multiplied together. Volume typically is easiest to find, but you do have to understand you need to find the area of one of the special bases first, then multiply it by the distance between the two bases of the prism. What's important to note here is that when I say base, it's base of a prism, the 3-dimensional figure, versus the base of the 2-dimensional figure. And you have to understand which one we're talking about here. For like the base of these prisms, right? I said the base is this side and this side. The base for the trapezoid is that side and the other trapezoid. The bases for the rectangle or for the triangle is for the top and the very bottom faces. And the base here, I just chose these. It doesn't matter. This one's can be chosen whatever way. But those are the bases of the prism. The base of a 2-dimensional figure is whatever you really want to make it. You have to adjust it around your mind so that it meets your needs. All right, here's the last problem. We have dirt must be excavated for a foundation of a building 39 yards by 21 yards to a depth of 8 yards. How many trips will it take to haul the dirt away if a truck with a capacity of 4 cubic yards is used? Now, we're just trying to haul away the dirt that's already in some space, right? We have some kind of ground here, and what we want to do is we want to cut into this a cube, or it's a rectangular prism, really. And we want to cut into it a place that looks like this and has a certain depth here. That's right. This is just the ground. And this is what we're trying to excavate out. This is the foundation. Now it says that it has a length of 39. Let me do this in a different color here. There's a length of 39 yards, 21 yards, and then it's 8 yards deep. So this rectangular prism here is just a lot of dirt. Now we have a truck that has a capacity of 4 cubic yards that can haul away the dirt. So if we can figure out how much volume this prism has, that's the same thing as how many cubic yards, because it's a volume, so it's in a cubic dimension. That's how much volume of dirt we have to move. And we can divide that by 4 to tell us how many trips the truck needs to take. So the volume of this thing is going to be, well, just length times width times height, really, because of the simplicity of a rectangular prism. It's the face of one of the rectangles, which is going to be like 39 times 21, and then the distance between the two faces, which is 8 yards deep. Okay, 39 times 21 times 8 gives us 6,552 going to be cubic yards or yards cubed. It's the same thing. And if the truck can haul away 4 cubic yards, that means it's going to take 6,552 divided by 4 trips, which is 1,638 trips, which probably means you need to find either a bigger truck or get a lot more trucks in your rotation. So this one was quite simple in the fact that it's a rectangular prism. If you had a triangular one, which would be weird if you want to make a foundation for that, then you have to use the base, the area of the triangle times the height between that. Here I did the area of the rectangle. This is the front face area of the rectangle times the height between the two faces. Trapezoids then the same kind of way.